actually trees. And we know that we have seen some examples of trees, then like the family tree, something like this, right? And ഇങ്ങനെയുള്ള ട്രീസിനെ പറ്റിയാണ് നമ്മൾ പഠിച്ചുകൊണ്ടിരുന്നത്. And in the case of we have seen that a tree is a collection of knots, right? Collection of knots. And the linked listum ഇതേപോലെ തന്നെ collection of nodes ആണ്, but the difference is that a tree is a two-dimensional data structure, whereas a linked list is a one-dimensional data structure. Then we saw a special kind of tree called binary tree. In the case of binary tree, a node can have a maximum of two children, and the starting node is always called the root, and these are all called leaf nodes. ഇതൊക്കെ നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ പഠിച്ചാണ് leaf nodes. And then the number of nodes in the longest path from root to a leaf is what you call the height of a tree, and the height of this particular binary tree is 1, 2, 3. So the height is actually 3 here. ഈ കാര്യങ്ങളൊക്കെ നമ്മൾ പഠിച്ചതാണ്. And then the level of a node, this has got level 0, this has got level 1, and this has got level 2. ഈ കാര്യങ്ങളൊക്കെയായിരുന്നു നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ പഠിച്ചത്. Then we saw some special cases like a full binary tree, complete binary tree. So these are the kind of things that we have studied in the last class. And ഒരു കാര്യം കൂടെ നമ്മൾ പഠിച്ചിരുന്നു, how to represent a tree. We saw that there are two different representations. The first is called the array representation, and second is the linked representation. In the case of array representation, suppose we have a tree like this. ഇതുവരെ നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ പഠിച്ചു. Suppose we have a tree like this. For example, this is A, B, C, D, E, F. ഇങ്ങനെയാണെന്നുണ്ടെങ്കിൽ we will make an array, and 1, 2, 3, 4, 5, 6, 7, 8. It goes like this, and this is the root node. Root node will stay here, and its children will stay at if a particular node is located at index I, its left child will be at 2i, and right child will be at 2i plus 1. ഇതാണ് നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ പറഞ്ഞത്. അപ്പോൾ a എന്നുള്ളത് 1 എന്നുള്ള ഇൻഡെക്സിലാണ് സ്റ്റോർ ചെയ്തിരിക്കുന്നതെങ്കിൽ its left child, which is b will be at 2 times 1, that is 2, and right child will be at 2 times 1 plus 1, that is ഇവിടെ. അടുത്തായിട്ട് b is at location 2, its left child will be 2 into 2, 4. Left child is b, right? And its right child will be 2 into 2 plus 1, that is. And then c is at 3, so its left child will be at 6, but unfortunately we do not have a left child here, so its right child will be at 2i plus 1. 2 times 3 plus 1 is 7, so f will be here. And ഇനി വരുന്ന ഒരു നോഡിനും d, e, f ഇതെല്ലാം ലീഫ് നോട്ട്സ് ആണ്, ഇതിന് ചിൽഡ്രൻ ഇല്ല, അതുകൊണ്ട് ഇനി നമുക്ക് അങ്ങോട്ട് എഴുതേണ്ട ആവശ്യമില്ല. This was actually called the array representation. And we saw the advantages and disadvantages. Advantage is that even though a tree is a two-dimensional data structure, we can actually represent it using a one-dimensional structure, right, which is an array. So two-dimensional to one-dimensional, that is actually the dimensionality decreases and also the complexity decreases. Then the disadvantage is that there can be a lot of void spaces, there can be a lot of vacant spaces in the array. So these are the things that we have seen in the last class. Now we move to our new topic, which is the linked representation of a binary tree. In the case of linked representation എന്ന പേര് കേൾക്കുമ്പോൾ തന്നെ നിങ്ങൾക്ക് അറിയാം, ഒരു ലിങ്ക്ഡ് ലിസ്റ്റ് പോലെ ആയിരിക്കും റെപ്രസെന്റ് ചെയ്യുന്നത്. നമ്മൾ ലിങ്ക്ഡ് ലിസ്റ്റിന്റെ കേസിൽ നമ്മൾ ഇങ്ങനെയൊക്കെ ചെയ്യുമായിരുന്നു. സോ we have the data part here, and then we have the link part here. Right? Again, we have the data part, we have the link part. We have the data part, and finally the link part. If the link part of the last node will be null. ഇവിടുത്തെ കേസിൽ എന്ന് വെച്ച് കഴിഞ്ഞാൽ ഒരു നോഡിന് ഒരു ലിങ്ക് അല്ല ഉള്ളത്, ഒരു ലെഫ്റ്റ് ലിങ്കും ഒരു റൈറ്റ് ലിങ്കും ഉണ്ടാവും, ഒരു ലെഫ്റ്റ് ചൈൽഡും ഒരു റൈറ്റ് ചൈൽഡും ഉണ്ടാവും. So what we do is, in the case of linked representation, if you want to represent this particular tree in the form of linked representation, what we do is the first node is A, and A will have two links. So we have a data part and we have two links. The first is the left link and second is the right link. So the left link will be to actually the node with the data part B, right? B. So in left link എന്ന് പറയുന്നത് ഇങ്ങോട്ടായിരിക്കും. And the right link will be to node with the data part C. Node, this is the node with the data part C. So you have, this is the data part, this is the left link, and this is the right link. So this is the structure of a node. ഇനി അടുത്ത ബിയുടെ എടുക്കുകയാണെങ്കിലോ, ബി ഹാസ് എ ലെഫ്റ്റ് ലിങ്ക് ആൻഡ് ബി ഹാസ് എ റൈറ്റ് ലിങ്ക്. വാട്ട് അബൌട്ട് ദ ലെഫ്റ്റ് ലിങ്ക് ഓഫ് ബി? ബി എന്ന് പറയുന്നത് ദാറ്റ് വിൽ ബി ടു എ നോഡ് വിത്ത് ഡാറ്റ പാർട്ട് ഡി. The right link of that will be to a node with data part E, right? അടുത്തായിട്ട് സിയുടെ കേസിലോ ലെഫ്റ്റ് ലിങ്ക്, ഇറ്റ് ഡസ് നോട്ട് ഹാവ് എ ലെഫ്റ്റ് ചൈൽഡ്, സോ ദ ലെഫ്റ്റ് ലിങ്ക് വിൽ ബി null. The right link will be to a node with data part F. Now the other nodes, D യുടെ ലെഫ്റ്റ് ലിങ്കും റൈറ്റ് ലിങ്കും എന്തായിരിക്കും? D does not have a left child, so that link will be null. It doesn't have a right child. E also has similar cases, and F also has similar cases. So this is the linked list representation of a, or linked representation of a binary tree. നമുക്ക് സാധാരണയായിട്ട് അറേ റെപ്രസെന്റേഷനേക്കാളും കൂടുതൽ നമ്മൾ ഉപയോഗിക്കുക ലിങ്ക്ഡ് റെപ്രസെന്റേഷൻ ആയിരിക്കും. So in the case of linked representation, we have nodes, or we have a collection of nodes. Each node will have a data part, a left link, and a right link. So this is actually a node in the case of linked representation of a binary tree. And what are the advantages and disadvantages here? The advantage is that ഇത് കണ്ടു കഴിഞ്ഞാൽ, ഈ ലിങ്ക്ഡ് റെപ്രസെന്റേഷൻ കണ്ടു കഴിഞ്ഞാൽ ആക്ച്വൽ ബൈനറി ട്രീയെ പോലെ തന്നെ ഇരിക്കും. സോ പിക്ചോറിയലി ഓർ ഇൻ ആൻ ഓർഗനൈസേഷണൽ വേ ബോത്ത് ആർ അലൈക്ക്. പക്ഷേ അറേ റെപ്രസെന്റേഷന്റെ കേസിൽ തിങ്സ് വെയർ ഡിഫറെന്റ്, ബിക്കോസ് ഇൻ ദ കേസ് ഓഫ് array representation, the representation was actually one dimensional even though the tree was two dimensional. But here that is not the case. The representation is two dimensional, the tree is also two dimensional. Again, the tree and the representation, they look alike, right? So this is the advantage of a linked representation of binary tree. പിന്നീട് അടുത്ത ഒരു കേസ് വെച്ച് കഴിഞ്ഞാൽ അറേ റെപ്രസെന്റേഷന്റെ കേസിലുള്ള വലിയൊരു ഡിസഡ്വാൻറ്റേജ്, ദാറ്റ് വുഡ് കണ്ടെയ്ൻ എ ലോട്ട് ഓഫ് വേക്കന്റ് സ്പേസസ്, ഓർ ദ size of the array can be quite large even though the tree is very small. But that will not happen here, because these nodes we can create in a dynamic way. അതാണ് ഇവിടുത്തെ ഏറ്റവും വലിയ അഡ്വാൻറ്റേജ്. സോ ദിസ് ഈസ് വാട്ട് വി കോൾ ലിങ്ക്ഡ് റെപ്രസെന്റേഷൻ ഓഫ് ബൈനറി ട്രീ. And here and in the coming topic, we will be mainly using this linked representation instead of the array representation. Array representation വെച്ചിട്ട് നമുക്ക് ഈ ട്രീ ഓപ്പറേഷൻസ് ഒക്കെ ചെയ്യാൻ പറ്റും, but that is a little bit harder to digest. So we will be using the linked representation. So do you understand the linked representation of binary tree? മനസ്സിലായോ? Can you type in the comments whether you understood it or not? Yeah, Parvati, right. Others, please, can you comment? Okay, Ruxana. Uh, should I repeat this or okay, Alina. I think this is a pretty straightforward topic. This one does not need much explanation. Now we are moving to the important topic of today, which is actually the tree traversals. Tree traversals. By traversal, we simply mean displaying all the elements. Means displaying all all elements. That is what we call traversal. We can have an array traversal. Suppose we have an array like this, A, C, D, E, B, something like this. We have an array like this. Then the array traversal will yield, or that will simply display all the elements of the array from left to right. So we have the left to right organization. First, we display A, then we display C, then we display D, then we display E, then we display B. So this is the array traversal from left to right. Similarly, we can have the array traversal from right to left. If we display it from right to left, it will be B, E, D, C, A. So we can say that there are two different traversals possible for an array, from left to right and from right to left. Uh, so traversal simply means display all the contents or all the elements of that particular data structure. Here tree is a data structure, and for tree we have sorry, we have three different traversals possible. And these traversals are, we have three different traversals possible, and these traversals are uh, pre-order, in-order, and post-order. These are the three different traversals possible for a binary tree: pre-order, in-order, and post-order. And the order in which array cases we had left to right traversal and right to left traversal. In the case of tree, we have pre-order, in-order, and post-order traversal. See, the problem that may arise with a tree is like, say, while traversing, you can see that we have a tree like this. This is A, B, C, D, E, right? The left child of A is actually B, right? And if you look the linked representation, it will be something like A. Here you have a B. Here you have a E, something like this, right? Again, this may have left and right children. The problem with a particular node is that for the node A, it knows its left child. It knows its left child because it has a link originating from this node to B, right? Similarly, A knows its right child because there is a right link. There is a link originating from A to the other node, which is E, right? But similarly, B knows its left child and right child, E knows its left child and right child. So these things are actually possible. But the node B does not know about its parent. ഇതിന്റെ parent ഏതാണെന്ന് ഇതിനറിയില്ല. കാരണം എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ there is no link originating from the node B to its parent node A. അതിന്റെ പേരന്റിലേക്ക് ആക്ച്വലി ലിങ്ക് ഒന്നുമില്ല. എയിൽ നിന്ന് ബിയിലേക്ക് ലിങ്ക് ഉണ്ട്, പക്ഷെ ബിയിൽ നിന്ന് എയിലേക്ക് തിരിച്ച് ലിങ്ക് ഒന്നുമില്ല. This was the case with the linked list also. Say you have this is the data part and this is the link part, right? Say here you have B. So A knows its rights, A knows its successor is B, but B does not know its predecessor is A because there is no link from B back to A. So that was the case with linked list. Similarly, in the case of trees also, there is a link from a particular node to its children. From A to B, we have link, but A to E, we have link. But there is no link from a node back to its parent. B യിൽ നിന്ന് A യിലേക്ക്. There is no link from E to A. There is no link. So that is one of the problems associated with uh, a tree. For the problem can be severe if we try to traverse a particular tree. This we everyone knows that this is what they call the root node. From A, first we are A, then we can actually go to either B or E. We know the children of A, R, B, and E. Suppose we are moving to E, sorry, we are moving to B. From B, we can actually move to C or D, right? Suppose we are moving to C, and from C, we cannot actually move anywhere. എങ്ങോട്ടും മൂവ് ചെയ്യാൻ കഴിയില്ല because C does not have any right child or left child. So in this case, uh, we are traversing, that is we are starting from one node and we are trying to move through the entire nodes, move through the entire nodes of the tree, right? We started at A. Ail നിന്ന് we can move to either B or E. Okay? And if we move to a particular node, we will print its data path. That is how traversal works. All right. If we move to B, we will print B. If we move to E, we will print E. Suppose we move to B, we can actually print this B. A already printed. A already printed, and then we move to B. We printed the data part of this node, which is B. Now we can move either to left or right. Suppose we move to left, and we can actually print C. From C, B, there is no going back to its parent node because C does not know about its parent. So this is the problem with a tree, a binary tree. That is why we need special techniques for tree traversals. So നമ്മൾ ഇതിന്റെ ഒരുപാട് ഡെപ്തിലേക്ക് പോകുന്നില്ല. Let's actually try to that find a way to print all the elements of this binary tree. We have three options. The first is pre-order, second is in order, and the last is post order. ഞാൻ ഈ പറഞ്ഞ തിരിച്ചു പോകുന്നത് ഫെസിലിറ്റേറ്റ് ചെയ്യാനായിട്ട് നോർമലി വി യൂസ് ദ ഡാറ്റ സ്ട്രക്ചർ സ്റ്റാക്ക്, ബട്ട് ആ ഡെപ്തിലേക്ക് ആ ഡീറ്റെയിൽസിലേക്ക് നമ്മൾ പോകുന്നില്ല. ലെറ്റ്സ് സീ വാട്ട് ദ ഡിഫറെന്റ് traversals of this tree are. First is actually pre-order. Pre-order has the uh, syntax node left right. So let's see what this is. Node left right. Node left right എന്ന് വെച്ച് കഴിഞ്ഞാൽ let's take a very small tree here. Let's take a very small tree. We all know that this itself is a tree, right? This is a binary tree. Its left child is null, right child is null, or it has the data part A, right? And if you traverse this tree, what should be the output? ഈ ട്രീക്കകത്ത് ആകപ്പാടെ ഒരു നോഡേ ഉള്ളൂ. ആ നോഡിനെ മാത്രം നമുക്ക് ട്രാവേഴ്സ് ചെയ്താൽ മതി. So if we traverse this tree, what should be the output? What should be the output? The output should be simply A. We are printing the data part, right? If we have a small tree here, we have a tree with only one node, and if we print its output, it will be simply A, right? Now let me make this tree a little bigger. We have B here, we have C here, right? Now there are three different traversals possible. Three different traversals എന്ന് വെച്ച് കഴിഞ്ഞാൽ you can first you can we know that traversal simply means displaying all the contents of the tree, right? So first traversal is we start from the first traversal is we can print it like ABC, right? ABC, that is possible. Another possible traversal is BAC, and the last possible traversal is BCA. Well, if this is too confusing, let's take it one by one. uh, we have uh, three different tree traversals. The first is pre-order, second is in-order, and the last is post-order. In the case of pre-order traversal, we have node left, right. So this is what we call the node. Node means whatever node we are currently in. ഇപ്പം നമ്മൾ എവിടെയാണോ നിൽക്കുന്നത് അതിനെയാണ് നമ്മൾ നോഡ് എന്ന് പറയുന്നത്. Originally or by default we will always start from the root. A is the root, right? ഇവിടെ പ്രിന്റ് ചെയ്യേണ്ട ഓർഡർ എന്ന് വെച്ച് കഴിഞ്ഞാൽ the order in which we need to print. First we need to print node, the data part of the node. What is the data part of the node here? It is A, right? Node. Then we need to print the data part of its left. What is the left here? It is B. And finally we need to go to its right, which is actually C. This is what we call the pre-order traversal. In the case of pre-order traversal, we first print the data part of the node, which is A, then we move left, where we will print C, then we will move right, which is actually C. So do you understand this pre-order traversal? This is just a basic explanation about pre-order traversal. We will have more complicated or more complex examples to follow. But do you understand what this pre-order traversal is? We have the order, we have the traversal order, node, left and right. Do you understand this, or should I explain this more? And checking your comments. Yeah, okay, Alina, Ristana, right. Actually, this should have been an offline class. Then, okay. കുറച്ചുകൂടി വലിയൊരു ട്രീ ആക്കാം. We have A, we have B, we have C, D, E, and possibly F here, right? This is a tree here, and the order in which we traverse will be node, left, right. We are checking at the pre-order traversal only. We are checking the pre-order traversal. So of course this is the root, right? So we are starting from here, and whenever we have, so this is actually a more complicated tree, right? ഇത് കുറച്ചുകൂടി complicated tree ആണല്ലോ. So here മുമ്പത്തെ കേസിൽ എന്ന് വെച്ച് കഴിഞ്ഞാൽ A, B, C. So you have a node here, you have a left child here, you have a right child here. The tree was over. But ഇവിടെ അങ്ങനെയല്ല, you have a node here. ഇവിടെ ഒറ്റ നോഡ് അല്ല ഉള്ളത്, you have an entire subtree here. You have an entire subtree, and on the right hand side also, you have an entire subtree. So here what we do is we have a node here, this A. So we will always print this node A. We will print, right? Then we have this part. Left is this thing, and the right is actually this thing, right? Left is this thing and right is this thing. So ഞാൻ ഇവിടെ A print ചെയ്തു, and after that let me draw the left part, which is D, E, and the right part is actually C, F, right? C, F. Now, okay, A I had already printed. The left is this thing B, D, E, and the right is C, F. Okay, A print ചെയ്തു, and what about this left part B, D, E? Can I traverse it in pre-order, or if I traverse it in pre-order, what is the result and that I am going to get? ഇവിടെ എനിക്ക് കിട്ടുന്നതെന്ന് വെച്ച് കഴിഞ്ഞാൽ what will be the result if I traverse this in pre-order? It will be node, then left. First it will be node, then it will be left, and finally it will be right. So the result will be BDE, right? So what I will do is I will replace this with BDE. BDE. And finally you have this right part, which is CF. CF. So what happens if I traverse it in pre-order? This is the node part, so this will be first, and the second should be the left child, and the third should be the right side. So I have C here, so I will replace it here. I will, the first should be C, the second should be the left side, but there is nothing on the left side, so I can omit that, and then the third will be actually F. So this is the actual pre-order traversal of this binary tree A, B, D, C, F. I'm not sure how many of you actually understood this. I will take another example and explain that. I will take one more example. Uh, so let me draw another binary tree here. I will draw another binary tree, which is A, B, C, D, E, F. Probably I will take another one, which is in fact G, F, right? So this is a more complicated binary tree. Let me try to find the pre-order traversal of this binary tree. This is actually the root. So pre-order means node, then left, then right. Correct. So we start from this A. Of course, we start from this A number start ചെയ്തു. What about the left part? The left itself is a subtree, right? So then I have this. I will draw it as a tree itself, BC. Then I have the right part. Right also itself is a subtree, right? Which is actually about D, E, F, G, H. With A, I have already got this. And now this thing, BC. BC, what will be the in order traversal of this BC? That means node left right, node left and right. Node is actually what? B, left is C, and the right is there. Right, there is nothing, right? So what I get is BC, and then there is nothing. So I can actually replace this with BC. I will just remove this and I will write this BC. And again, the right part looks a little more complicated, but let's analyze, or let's try to draw it in the same fashion. We have D, E, F, G, and H, right? Again, it should be node left right. What is this node? We are starting from this root. This is the first part. Then the second part itself is actually a subtree. This is 2, and then the third is 5, right? So again, I will replace it this with first is D, second is actually a subtree itself, which is E, G, H, and the last is third. We have only one thing, which is actually F, right? Then we have one more. The traversal is not of it. We have this EGH, EGH. Again, node left, right. So what should be the expansion here? EGH. So this subtree I will replace with EGH. EGH. So this is the actual pre-order traversal of the binary tree on the left hand side. So do you understand this? Do you understand how we can perform the pre-order traversal of a binary tree? Do you understand this? മനസ്സിലാകുന്നുണ്ടോ? Can you type in the comment, or should I explain this more? Okay, Parvati, Manu, Alina, Akshay. So this should be very easy, right? So if you know this concept, that is pre-order is nothing but node left right, then any binary tree you are given, you can easily make the traversal out of it. So now let's move to the next type of traversal. ഒരെണ്ണം മനസ്സിലാക്കി കഴിഞ്ഞാൽ പിന്നെ ബാക്കിയെല്ലാം വളരെ എളുപ്പമാണ്. Next type of traversal, which is actually uh, in order. In order എന്ന് പേര് കേൾക്കുമ്പോൾ തന്നെ അറിയാം. In order. So pre-order means node comes at the beginning. Node comes at the beginning. Then you have left, right. This left, right എന്നുള്ളത് എപ്പോഴും ഒരേ ഓർഡറിലായിരിക്കും. You will have always left and then right. So node comes at the beginning means pre-order. Then the next is actually in order. In order means node comes in between. എന്ന് വെച്ച് കഴിഞ്ഞാൽ എങ്ങനെ വരും? So you will have left, then you will have node, and finally you will have right. Left, node, right. This is what you call in order. Left, right എപ്പോഴും ഒരേ ഓർഡറിലായിരിക്കും. And the depending on the position of the node, you will have pre-order, in order, and post order. Pre-order means node is at the beginning. In order means node is in the middle, and post order means node is at the last. So in order simply means left, then you have left, then you have node, and finally you have right. അങ്ങനെയാണെങ്കിൽ ഈ പറഞ്ഞ റൈറ്റ് ട്രീയുടെ ഗ്രീൻ ട്രീയുടെ ട്രവേഴ്സൽ നമുക്കൊന്ന് നോക്കാം. ഇനോർഡർ ട്രവേഴ്സൽ നമുക്കൊന്ന് നോക്കാം. ഇനോർഡർ ട്രവേഴ്സൽ എന്ന് വെച്ച് കഴിഞ്ഞാൽ ഫസ്റ്റ് we are trying about this green tree. First you need the left part, right? Then you have node, and then you have right. ഇവിടെ നോഡ് എന്ന് പറയുന്നത് this is actually A. And what about the left part of this tree? Left എന്ന് പറയുന്നത് it's actually a subtree, right? B, D, E. Then you have the node. Node is actually A, and finally you have the right. Right is also a subtree, which is C, F. Correct? അങ്ങനെയാണെങ്കിൽ ഇവിടെ ഒരെണ്ണം മാത്രമേ നമുക്ക് ഇവിടെ കിട്ടിയിട്ടുള്ളൂ. We have trees on the left and right. Can we expand the left tree on the in order format? Left tree എന്ന് പറഞ്ഞാൽ എന്ത് വരും? B, D, E. B, D, E. ഇതിനെ in order formatലാക്കുകയാണെങ്കിൽ left, node, right. What about left? Left എന്ന് പറയുന്നത് ഇപ്പം ട്രീ അല്ല, this is ഒരു നോഡ് മാത്രം. Left is actually D, right is B. Sorry, not right. Left is D, node is B, and this is left, node, and right. Left is D, node is B, and the right is actually E. B, B, E. അങ്ങനെയാണെങ്കിൽ നമുക്ക് we can replace this thing with D, B, E. D, B, E. And then we have the right. Right എന്ന് പറയുമ്പോൾ again we have a tree. Tree എന്ന് പറഞ്ഞാൽ we have C, F. C, F. What about the left child of C? There is no left child for this C, right? It has only a right child. അപ്പോൾ ഇതിന്റെ traversal it will be left, not right. Left, node, and right. Left there is nothing. Node it is C, and the right is actually F, CF. So can I replace it with CF? Yes. CF. So this will be the in-order traversal of the binary tree, which is actually shown in this green. Do you understand this in-order traversal? മനസ്സിലായി in-order traversal എന്താണെന്ന്? In-order traversal, has everyone got this? Pre-order മനസ്സിലായ? It is easy to find in-order also. Oh yeah, Akshay, okay. Yeah, Manu, right. Okay, Ruxana, okay, okay, right. എല്ലാവർക്കും മനസ്സിലായിട്ടുണ്ടാവും. അങ്ങനെയാണെന്നുണ്ടെങ്കിൽ ഈ ബ്ലൂ ട്രീ ഓൺ ദ ലെഫ്റ്റ് ഹാൻഡ് സൈഡ് അതിന്റെ ഇനോർഡർ ട്രവേഴ്സൽ ഒന്ന് കണ്ടുപിടിച്ചിട്ട് ചാറ്റ് ബോക്സിൽ ഇടുന്നു. Can you do that? Can you find the in-order traversal of the tree on the left hand side and type in the chat window? Just try doing this. Maybe I will give you 2 minutes. ഒന്ന് പെട്ടെന്ന് കണ്ടുപിടിച്ചിടാമോ? ഈവൻ തെറ്റിയാലും കുഴപ്പമൊന്നുമില്ല. ഈ ഒരു പാറ്റേൺ മാത്രം നോക്കിയാൽ മതി. ലെഫ്റ്റ് നോഡ് റൈറ്റ്, ഇതിൽ സിംഗിൾ ആയിട്ട് വരുന്ന സാധനങ്ങളെല്ലാം നിങ്ങൾക്ക് അതേപോലെ പ്രിന്റ് ചെയ്യാം. അതൊരു സബ് ട്രീ ആണെങ്കിൽ അതിനെ വീണ്ടും ഇതേപോലെ തന്നെ എക്സ്പാൻഡ് ചെയ്യുക. ഈ എക്സാമിന് ഇതേപോലുള്ള ക്വസ്റ്റ്യൻസ് സാധാരണ ചോദിക്കാറുണ്ട്. ഒരു ട്രീ തന്നിട്ട് ഫൈൻഡ് ദ ഇൻ ഓർഡർ, പ്രീ ഓർഡർ ആൻഡ് പോസ്റ്റ് ഓർഡർ ട്രാവേഴ്സൽസ്. I'll give you 1 more minute and you find the in order traversal. Okay, a few of you have already written this thing. നമുക്ക് നോക്കാം. So here we always start from this rule. You need left, not right. This is the node. The left is, so when you start this, the left is actually BC, the node is A, and the right is D, E, F, G, H. And ഈ ബി സി എന്നുള്ളതിനെ മാറ്റുമ്പോൾ ലെഫ്റ്റ് നോട്ട് റൈറ്റ് ഇല്ല, സോ ദിസ് വിൽ ബി സി ബി വരും അല്ലേ. സോ ഐ വിൽ സിംപ്ലി റൈറ്റ് സി ബി ആൻഡ് നോഡ് കഴിഞ്ഞു. ഇനി റൈറ്റ് വരുമ്പോഴത്തേക്ക് ലെഫ്റ്റ്, ദിസ് പാർട്ട് ഈസ് ആക്ച്വലി ദ ലെഫ്റ്റ് node is this thing and the right is this one, right? And so what you can do is EGH, EGH ഇതാണ് ആദ്യം വരേണ്ടത്. ഇതിനെ തന്നെ ഒന്ന് ഇനോർഡർ ആയിട്ട് ചെയ്യുമ്പോൾ this is 1 2 3, so GEH എന്ന് വരും, right? So this will be nothing but this will be expanded to GEH, and then this was one, then you had D and F. So the final result would be GEH D F. So this is the final in order traversal of the binary tree given here. So many of you have got it correct, and I think you are doing pretty well. Now there is one more and we will wind up. And what is the last kind of tree traversal? That should be actually called the post order traversal, right? That should be the post order traversal. So in the case of so the last thing will be post order. Post order എന്ന് വെച്ച് കഴിഞ്ഞാൽ it depends, the name of the traversal actually depends on the position of the node. You had pre-order means node is at the beginning. In order means node is in the middle. And post order means node is at the last. So you have left, then you have right, and finally you have node. This is what you call post order. Left, right, and node. ഇത് സിമ്പിൾ ആണ്. ഇത് മുമ്പ് പറഞ്ഞ പോലെ തന്നെയാണ്. And so let's take the green tree on the right hand side. What will be the post order traversal here? You have left, node, and right. So left is actually a subtree here. Node is A, and the right is C, F. This is actually, sorry, the other way. I'm sorry. Left, right, and node. Left is BDE, and right is CF, and the node is actually A, right? അങ്ങനെയാണെന്നുണ്ടെങ്കിൽ ഇതിനെ വീണ്ടും നമുക്ക് എക്സ്പാൻഡ് ചെയ്യാം. സോ ദിസ് ഇസ് BDE. ഇതിനെ പോസ്റ്റ് ഓർഡറിൽ എങ്ങനെ എക്സ്പാൻഡ് ചെയ്യും? ലെഫ്റ്റ് റൈറ്റ് നോട്ട്, ലെഫ്റ്റ് റൈറ്റ് നോട്ട്. So what should be the expansion? Is DEB, DEB, right? So this will be actually expanded to DEB. What about the CF? CF നെ നോക്കുകയാണെങ്കിലോ, the CF will be again left right node, left right and node. So what should be left? There is nothing. Right, you have F, and the node is actually C. So this will be actually expanded to FC, right? This is FC. FC, and then the last part, A. So this is the post order traversal of the binary tree which is given here. So the case of post order, we have left, right, and node. That's all. ഇങ്ങനെയാണെന്നുണ്ടെങ്കിൽ can you write the post order traversal of the blue tree on the left hand side? അതൊന്ന് ചെയ്ത് എഴുതാമോ മുമ്പത്തെ പോലെ? Again, I will give you 2 minutes. What should be the post order traversal of the blue tree on the left hand side? Can you type in the chat window? Has anyone written it? Yeah, C, D, G, H, D. Okay, that's correct. So it's easy, right? So let's do this. You have left, right. No, left is this BC, right is D, E, F, G, H, and the node is actually A. And the left part BC, BC means left, right, no. So this will be expanded to CB. This will be simply expanded to CB, right? So this is CB. and right, the next is this thing, which is D E F G H. ഇവിടെയും the left is actually a subtree. So this is 1, this is 2, and this is 3. ഈ 1 എന്ന് പറയുന്ന സാധനം നമുക്ക് ഒന്നുകൂടെ നോക്കുവാണെങ്കിൽ ഇ ജി എച്ച് ഇതിനെ നമുക്ക് എക്സ്പാൻഡ് ചെയ്യുകയാണെങ്കിൽ ലെഫ്റ്റ് റൈറ്റ് റൂട്ട്. So it should be GHE. This should be GHE. Then ഇതിനെ നമുക്ക് GHE വെച്ചിട്ട് റീപ്ലേസ് ചെയ്യാം. This will be expanded to GHE. So this the final thing will be like GHE, F, and D. So this entire thing will be expanded to GHE, FD. So this should be the final output of the post order traversal of this tree. So I think many of you have again got it right. So I think you have got the concept how to write the in order, pre-order, and post order traversals of a binary tree. So in today's class, we have seen the linked representation of a binary tree, and most importantly, the various tree traversals. ഏതൊക്കെയായിരുന്നു tree traversals ഉണ്ടായിരുന്നത്? You have pre-order, in order, and post order. And these nomenclatures or the naming actually is derived from the position of the node. Always you have first left and then right, and depending on the position of the node, then you will have pre-order, in order, and post order. Pre-order means node left right, in order means left node right, and post order means left right node. And we have done some examples of these kind of tree traversals also, and I think you have got the idea of these kind of binary tree traversals. And with this, let's wind up today's class. Any question?